Hello everyone, hope you are doing well. With this pandemic, you have to be careful, your family, yourself. So, let's discuss one vital topic. This topic is we can title with this inductance of two-wire transmission. What is the term is inductor? With this, we will be discussing some key elements, the inductance, what is the flux linkage, and the magnetic field intensity. So let's start with the first, the aim of this. Just we have to focus on this. The aim of this topic is what? The objective is the first we have to see the two-wire line. What two-wire line? So this is the two-wire line we previously also discussed. The topic of the capacitance we have discussed, the two-wire line capacitance, how we know. This is why this two-wire line is required. So this is nothing but the power transmission line, means transmission line. It's transport the power from source to load basically. So now see that what is the inductance? The inductance, as you know, the term is the flux linkages per unit current. Means this current what? If suppose one conductor is there, if you see it will be clear for the 3D. Suppose here two transmission line you said. So the transmission line, suppose here one transmission line, one conductor, like a conductor, and here also one conductor. If you see that two conductors are placed in the direction of Z. Suppose here it is X, Y, and along this Z. The conductor radius is, we are considering the radius from origin to this is R, capital R. Okay. If this conductor is carrying the current is in this way, I direction, and but this would be the current carrying in this way. So as we know, suppose if you consider this as a go conductor, and you have to consider this one as a return conductor. Either way you can consider whatever the term. So now if the plane rotation, if you see use for this conductor is what? From if a particular this plane is there, so current is coming in and this going out. The going out is coming in. So it can be present as a cross, it can be present as a dot. As you know, there is a convention of in a plane, if you present the cross and dot, we present. So see, here is the 3D diagram. There no meaning of this cross and dot is there. If 3D presentation is not there, only we have used the dot and cross, but here no meaning of that. In this way current is carrying, going, and this way is current is returning. Okay, and this is we are considering as an infinite long carrying conductor. And suppose we are taking this current carrying conductor, carrying current is what? I, and this would be the minus I. Okay. So now what? This flux linkage, what we know that flux linkages means what? The number of turns into a flux. And number of turns into flux. So this flux, for this flux, from where it will come? It will flux due to the magnetic field intensity. And magnetic field intensity due to what? The current is carrying, because the conductor is due to I current, the magnetic field is there, means the flux is there. If flux linkage is there, so only the inductance also be there. Okay. For this inductance is what we know, the for inductance, inductive part, only their reactive component will be there. Means there will be reactive loss. There will be no active power loss. Okay. So, but in case of power transformation, you can't avoid it. It would be there only. Okay. In practical case, it would be there only. Okay. So, now before going to this flux linkage, there will be two types of flux linkage. One is external flux linkage, and another one is internal flux. So, external and internal, what is the meaning of that? External means what? This conductor is with the radius of capital R. So, if this conductor is carrying I, within that conductor, what would be the electric field intensity, magnetic field intensity? So that is one notation will be there. This flux would be different, and the outer of the conductor. Suppose here, here. What would be the magnetic field intensity? It would be different from this. Okay. So now we have to discuss the with inside of this conductor what flux will be getting, magnetic field intensity, and for this magnetic field intensity what flux will be getting. That flux is known as the external flux, and this flux is external flux. So magnetic field intensity for magnetic field intensity external is creating the external fluxes, and magnetic field intensity the internal means inside the conductor, that is creating the internal flux. So for this flux there is a linkage, and for this flux there also the linkage. So these are the two linkages, flux linkages. Okay, external flux and internal flux linkages. Clear? Now as we know, this notation we got, as you know, the firstly the for infinite long carrying conductor, what is the magnetic field intensity? Magnetic field intensity simply we know that I is the current carrying conductor, magnitude of the current, 2 pi rho a phi. If we represent, it is in what? It is in cylindrical coordinate. Okay. Now this notation is it correct? Is it correct? It is correct. But in case of conductor, some modification is there. As you know that infinitely long carrying conductor, from the conductor to anywhere some point you will be getting. So from that point, if we see this, it will be the expression. But inside the conductor, what is happening, that we have to know. Okay. So now here we can explore the Ampere's circular law. Ampere's circular law, if we apply. So as we know the what Ampere's circular law what says? It is says that the current enclosed. So H dl the enclosed current. So as we know, suppose if we consider this is the radius of R. Suppose inside some radius, if I am considering with this as the rho, considering this radius as a rho in cylindrical coordinate from origin to this point would be rho, and there is a extra small changes, suppose d rho it would be. So for that, what would be the, we know that this component is phi would be, and only elemental change for this line elemental change what for cylindrical coordinate, do rho and rho d phi a phi plus dz az. Clear? Now, as we know, this only this phi component is present for this infinitely long. If you apply the thumb rule, so if you see that there only the phi component is present, only this component is present in along this direction. So what do we know though? For cylindrical, only is this direction means what? Phi, a phi. So this is the phi direction, a phi. And what would be the present line element for this? If it is phi, so only this component will be there. So only phi and 2 pi. Okay, it is from what? Phi is, we know, the 0 to 2 pi. Okay, it was d phi, so that means total is 2 pi d phi. Sorry, if we erase this, firstly it will be d phi. Okay, and now what is the enclosed current for this? So we know this is the enclosed cross section is what? So cross section is for this pi r square, as we know. So for the pi r square cross section, capital R square cross section, the current is what? You know, the I current is flowing. But for pi r square, what would be the current? Rho square r square into I. This is the enclosed current. So for the inside conductor, what would be the enclosed current? So this would be enclosed current, rho square r square into I. This would be the enclosed current. Okay. Now, if we represent 0 to phi, okay, so for this whole radius, okay, so what would be? Rho phi into rho into 2 pi. Clear? And here rho square r square into I. That means a phi is rho 2 pi capital R square into I. So this is nothing but the magnitude only. Okay. If you represent in the vectorial form, vector field, so this would be the, sorry, it will not be there, this component like only this rho 2 pi R square I into a pi. This will be the expression. Clear? Now, this is what? This is the internal magnetic field intensity, the inside of the conductor. For this magnetic field, the flux will create, and for this flux there will be linkage, and for this linkage there will be inductance, part of inductance. Clear? And now what would be the external magnetic field intensity? So what would be the magnetic field intensity external? So let's see the. So now external means what? As I said earlier. So this is the surface from origin to this up to this R. From this R origin to this is R. Means from that point to anywhere the point. Suppose here we small with this rho we considered one radius. Now suppose rho is somewhere here. Rho is somewhere here. Otherwise rho is somewhere here. So what? Rho is increasing. Na? Up. Rho is here greater than R. For the case of external magnetic field intensity, rho is greater than R. But for rho, that internal, rho is less than R. It was rho less than R, but now the rho is greater than R. But now what? Here again, if you include the Ampere's circuital law, then H rho 2 pi will be getting, and the enclosed current, what would be the enclosed current? So enclosed current is the maximum I, na? So whatever the point is there, the enclosed current would be the only I current. With this, the I maximum I current only is flowing through this conductor. So enclosed current would be the I only. Okay. Now this is expression is what would be getting? The I 2 pi rho A phi. Phi is not there because here it is the magnitude only we are considering. Okay. Here is the magnitude only. Okay. Now if you present in the vectorial form, so it is 1 by 2 pi I A phi. Okay. So in the beginning, what we know that in the for an infinitely current carrying conductor, okay, so magnetic field intensity is nothing but 1 by 2 pi rho A phi. Means what was the meaning of that? Suppose this is current carrying conductor 1. So from that somewhere here is the distance, the radius is very distance, this distance is so far than the radius. For that case, this expression is suitable. Okay. So this expression nothing but the for a conductance, if inductance if you studying means for conductor to a line conductor. So there would be this one would be the external magnetic field intensity. So if it is the external magnetic field intensity, for this the flux will be there obviously. Here also if flux is there, there also obviously linkage with that conductor. So with if linkage is there, so obviously there would be the inductance. Okay. So before leaving this, I want to plot in a graph. Okay, this how this the magnitude of magnetic field intensity, how it is varying. So this is I rho 2 pi r square. When rho less than r, r is the radius of that conductor. At h would be the I 2 pi rho when rho is greater than r. Okay, this is the mathematical expression. Clear? Now it is would be the 0 to rho r and it is greater than r. Okay. Now if you represent in this way, this is the rho direction. The rho as we can consider as a parameter variable. So this is the h magnitude. So suppose if you consider this is as a radius of, this is the radius. Now the varying with this in this way, the magnetic field intensity is varying proportional to rho, and with this is the exponentially decreasing. Okay, in this question inversely decreasing. Okay, so for this magnetic flux we will be getting the external flux linkages. For this we will be getting the internal flux. linkages. Okay. Before going to what is the flux linkages, what are the external flux linkages, what are the external magnetic field intensity, what are the internal magnetic field intensity. Okay. So, for how it would be utilizing in the calculation of inductance. Okay. So, in the next we will be deriving the expression for the inductance for a 2-wire transmission line. Okay. The expression I have discussed here, it is only in the cylindrical coordinate system. If still you have some doubt on this cylindrical coordinate system, the link of the cylindrical coordinate system, so that is in 3D only. You will get a crystal idea of the cylindrical coordinate system. Okay. Thank you all, and hope you have understood this topic and this is the element. And if any doubt you have, then obviously you will comment on the comment box. Okay. And you can directly mail me, you can directly ask me, you can WhatsApp me. Okay. Thank you all. Best of luck.